So we continue with the exercises. So 4. So let phi of r equal to 1 by 2 pi log r if n equals 2 and minus 1 by n minus 2 alpha n r to the 2 minus n if n is greater or equal to 3, where alpha n equals surface measure of unit ball in Rn. So recall that this is the fundamental solution of the Laplace operator. We have delta phi equal to delta as we have seen earlier in the chapter on distributions. Okay. So A, let x belong to omega. So there exists a unique solution phi super x such that delta of phi x equal to 0 in omega and phi x of y equals phi of mod y minus x for all y in gamma. Okay, so omega in Rn bounded open set and gamma equals d omega as usual. Okay, so now, so if x is in omega, then for every y in gamma we have x is not equal to y. So phi of mod y minus x is a smooth function, implies there exists a unique solution of above problem. Unique weak solution, and then because everything, if omega is smooth, then it will also be a smooth solution. Okay, so B. So let phi x belong to h2 of omega for every x in omega. Okay, so this is not very difficult to get. If you have a weak solution, then by regularity theorems you can easily get it for omega sufficiently smooth. Okay, assume u is in C2 of omega bar such that minus Laplacian u equal to f in omega and u equal to g on gamma. Then for every x in omega we have the representation formula ux equal to minus integral on omega f g of xy dy plus integral on gamma g of y dg by d nu of xy d sigma y where g of xy equals phi of mod y minus x minus phi x of y. Okay, so this is called the Green's function. So we can represent the solution of the Laplace operator in terms of the Green's function. So this is called the Green's function. So for different domains we try to calculate g, then you can get explicit formulae for the solution of the equation. So it can be done with simple geometries like half plane, circle, etc. Okay, you might have seen it in your PDE courses. Okay, classical PDE courses, such formulae are familiar. Okay, so now let us try to prove this. So the existence of a Green's function is clear. If the Green's domain is sufficiently smooth and the data is also smooth, then you have a representation formula in terms of the Green's function. So solution omega epsilon you put as omega minus b of x epsilon bar, where epsilon greater than 0 such that Bx epsilon is contained in omega. So, you have omega here and you have x and you have a small ball around it, and what you have outside is omega epsilon. Okay. So, now we apply Green's identity. So, you have that integral on omega epsilon of uy delta phi of mod y minus x dy, or rather minus, so let me put a bracket here, phi of mod y minus x delta uy dy is equal to integral on d omega epsilon of uy d phi by d nu mod y minus x minus phi of mod y minus x du by d nu at y d sigma y. Now, y is in omega epsilon, that means y is not equal to x, okay, because x is the center of this ball which we have excluded from the omega epsilon, and this implies phi of mod y minus x is harmonic. Therefore, this integral will go off to 0. Okay. So, then you have d of omega epsilon is nothing but d of omega union s epsilon, where s epsilon is set of all y in omega mod y minus x equal to epsilon. That means you have the sphere, this is the boundary of this, and so this is s epsilon. Okay. Now, since everything is smooth, integral on s epsilon of phi of mod y minus x d nu du by d nu of y d sigma y. Now, all these are bounded on s epsilon, there is no problem, and therefore, this is less than or equal to some c times epsilon power n minus 1, because the radius, the volume, the surface measure of s epsilon is epsilon power n minus 1 times alpha n. Okay. So, this whole thing is less than c s n epsilon, and that goes to 0 as epsilon goes to 0. Now, what about integral of s epsilon of uy d phi by d nu mod y minus x d sigma y. Okay. Now, if you go back to the calculations which we did when computing the fundamental solution of Laplacian, then you perform the same calculation. So, this will converge to minus u of ux as epsilon tends to 0. So, that is, so C computations of fundamental solution of delta. Okay. So, if with these two, so if we rewrite the previous thing, so you will get, so the whole thing if you rewrite it, so you will get ux will be equal to integral on omega as epsilon goes to 0 delta y delta uy phi of mod y minus x dx. So, this is as epsilon goes to 0, okay, plus integral on gamma u of y d by d nu phi mod x minus y d sigma y minus integral on gamma phi of mod x minus y du by d nu d sigma y. So, this is just got by writing integral on omega epsilon. Omega epsilon is sum of these two. So, you have sum of two integrals. The integrals on s epsilon we have evaluated, taken the limits, and then the integral on d omega, which is gamma, which is remaining, and then you have this extra term here. And so, if you use these two properties here, then you will get this following relationship. Okay. So, now apply Green's identity to u and phi super x, because that is in H2, I can apply that also. So, integral on omega u delta phi x, again that is 0 because it is a harmonic function, minus phi x delta u of y, u y phi x of y, okay, dy, okay, and equal to integral on gamma u y d phi x y by d nu minus du by d nu of y phi x of y d sigma y. Okay. So, if we rearrange this, so you will get 0 equal to integral on omega delta u y phi x of y dy plus integral on gamma u y d phi x by d nu, sorry, this will be with the minus sign. Okay. So, this is, let me rewrite this correctly. I am bringing everything to the left hand side. So, u of delta u of y into minus phi x y, okay, for some reason I am going to write like that, and then plus minus u y d phi x by d nu at y d sigma y plus integral on gamma phi x of y du by d nu y d sigma y. Okay, so now let us add these two. So, adding 1 and 2. So, this is 1 and this is 2. So, you get u of x equal to integral on omega, you have delta u y into, so you have phi of mod y minus x minus phi x of y dy, and then plus integral on gamma, okay, here u y into d by d nu phi of mod x minus y minus phi x phi x of y. So, d by d nu of all this into d sigma y, okay, and then minus integral on gamma du by dy du by d nu at y phi of x minus y minus phi x of y d sigma. Now, we do not know anything about du by d nu, but this is precisely the reason, because phi of y x minus y minus phi x of y is equal to 0. So, that is how we define phi x, this condition, and therefore, if we, so this term vanishes because this is equal to 0 here. And now, phi of y minus x minus phi x of y is precisely g x of y. So, u of x equals integral on omega delta u g of x y dy plus integral on gamma u of y d by d nu of g of x y d sigma y. Now, you put in the values of delta u and u. So, this is minus integral on omega f of y g of x y dy plus integral on gamma u y gy dg by d nu of xy d sigma of, and that is exactly what we wanted to prove. So, this is the formula for the solution provided the domain is smooth, and if you have, when you take into account the Green's function, which is good enough. Okay. So, before quitting this session, I just wanted to, I should have done this earlier, but probably here are some errata which I wanted to correct. So, system of elasticity, you might have already figured it out. So, we had this, we had that V in d of omega, and then we took V equals V 0 0, 0 V 0 and 0 0 V when finding out the way they recovering the differential equations, and then we get that minus sigma j equals 1 to 3 d by dxj sigma ij of x equals fi in omega I equals 1 to 3. So, the mistake was I had put here sigma over ij, and that is wrong, and therefore, it is just sigma over j equals 1 to 3, you get this. And then similarly, another sigma was missing, that was integral on gamma of sigma over ij equals 1 to 3, sigma ij of u vi nu j d sigma equals integral g dot v over gamma d sigma, okay, for every v, okay. And this again, from this we deduce that again using the v equals v 0 0 0 v 0 0 0 v in h1 of omega. So, you get again the sigma was missing this time again. So, this is sigma j equals 1 to 3 sigma ij of u nu j equal to gi on gamma I equals 1 to 3. So, there were various sigmas which were missing in that thing. So, please you might have noted it already, if not please make correction. Okay.